last one of the three that'll be on the quiz: reflections, translations, and now rotations. And I was pretty adamant on Friday, and I know most of you didn't care, but I was pretty adamant on Friday when we did reflections. I said, use a lowercase r. Do not use a capital R because that's reserved for something else. And here's what it's reserved for. We use capital R when we want to do a rotation. Okay, lowercase r, strictly reflection. Capital R, rotations. You will also see a number in the subscript. A number. So let's put a 90 here, 90 degrees in the subscript. That will tell you whatever's there is how many degrees we're going to rotate. And for you guys, all you have to worry about is 90, 180 degrees, and 270 degrees. And I'll show you why when we get into it. But here's the problem. I could rotate one of two ways. I could rotate in what's called a clockwise direction, so going to the right, or I could rotate in a counterclockwise direction, going to the left. How are you going to know which direction to rotate? All depends on the degree measure. If it's positive, like it is right now, if it's positive, all right, and this might not make too much sense here, but this is the way it is. We're going to rotate. If it's a positive degree measure in your subscript, you rotate counter 90 degrees in this case. 90 degrees counterclockwise. Counterclockwise. And I know most of your clocks, watches are all digital, but we got to go old school. All right, so we're going counterclockwise, right? Counterclockwise. And just so if you want some type of way to remember counterclockwise, I don't know if you guys are familiar with your quadrants, but the quadrants are labeled in a counterclockwise fashion. 1, 2, 3, and 4, right? That's how they're labeled, counterclockwise. So if that helps you remember. All right, well, what happens if I want you guys to rotate in the other direction, going clockwise? Well, instead of a positive degree measure, you're going to see negative. So rotate negative 270, which means let's rotate my figure 270 degrees, but now in a clockwise direction. So positive, we're going to rotate to the left, counterclockwise. Negative, we're going to rotate to the right, clockwise. Or it'll just come out and say do it counterclockwise or clockwise. I don't have to worry about if it's positive or negative. All right, we got to move, so here we go. Go ahead and graph triangle DEF. I'll give you a minute to do that, and then we're going to do our first rotation. All right, we all have it graphed. We're going to take this triangle, directions 90 degrees, counterclockwise. So think about counterclockwise. We're going to the left, right? Counterclockwise. So take a look. E prime should end up down here somewhere in quadrant 3. And F and D should end up somewhere in quadrant 2 if I'm going counterclockwise. So mentally, I'm just trying to get a picture in my head. These two will end up in quadrant 2. E should end up in quadrant 3. So how do we do these rotations to find out where they land? This is where the physical part comes in. Everyone take your paper right now. This is why we're only going to rotate 90, 180, and 270. We're going to take your paper right now and rotate it 1/4 turn, 90 degrees, to the right or left, counterclockwise. To the left. So everyone right now, ready? Here's your paper. We're going to rotate it 1/4 turn to the left. Keep it there. Now you're staring at a new XY axis. You're staring at a new XY axis. What I want to know right now from somebody is, where is your point D right now? Because it is not at 2, 3 any longer. It's somewhere new. Name that new point D is on right now. Name that new point because we're going to jot it. I know it's going to be kind of odd, but we're going to kind of jot it down sideways here. So where is your new point D right now that we're going to call D prime? Where is it? I just want to jot it down. I do not want to graph it. Where's point D? Because it's not at 2, 3 anymore. It's at -3. Everyone see it? It should be at -3, 2. Yes? No? When you rotate it, over to the left 3, down 2. So just jot down D prime is at -3, 2. Where's E now? So make sure your paper is turned back to 1/4 turn to the left. Where is point E? Look at point E right now because it's no longer at -1/6. Where is it? Anybody have it? -6, -1. Yes, no? Tell me here. -6, -1. All right, so I jot that down. And do the same thing for F. Where is F prime on your axes now? Where is F? Where did F move to? -6, -6, +2. Before I move on to the next step, are we all right? All right, now we go back to the beginning, and now we graph it. All right, so I turned my paper. I rotated it 1/4 turn to the left, wrote down where the new points were, and now I go back to my original graph and graph it. And you should see all points have been rotated 90 degrees to the left. Good. And just to show you guys where the 90 comes in, how do you know you actually did 90 degrees and not like 80, 70 degrees? We always, in this class, we're always going to rotate around the origin, 0, 0. And I'll just do this on mine. If I connect one of my pre-image points, let's say I connect D to the origin and D prime to the origin as well. Guess what type of angle I just made there? That's the right angle, 90 degrees. I just rotated it through 90 degrees. So that's where that 90 comes in. Real quickly, what are the others? I mentioned you could rotate. Ready? 90. Another one would be, two turns would be 180. And then 3 turns would be 270. And if I do 4, I'm back to the beginning at 360. I never have you do that. But 90, 180, 270. It's just a matter of, do I turn it to the right clockwise or do I turn it to the left counterclockwise? All right. Last thing before we really get fired up, down at the bottom of your page, I respect and understand that some of you are not going to be comfortable rotating your paper. That just blew your mind, some of you, right there, rotating the paper. You were lost in the sauce. And that's fine. So for you guys, I wrote the rules, if you'd rather memorize the rules. So if you're going to rotate 90 degrees, so counterclockwise, just like we did, you take your coordinates, flip them, and change the y value there. You change the sign on the y. This is for if you want to memorize. If you're not comfortable turning. All right, if you're not comfortable turning, I wrote the rules for you right here. Now you'll notice before I move on, I only put the positive, 90, 180, and 270. What happens if I wanted you to go -90? I don't have that rule written. Oh, it's up there. Anybody know -90 is the same as which rotation up here? For some of the clever ones here. 270. So this right here is the same as -90. This is the same as -180. And this is the same as -270. All right, so all rules are up there. That's for anybody who wants to memorize. They're there. Okay, they're there. If you want to keep turning, you turn. If you're uncomfortable turning, memorize the rules. You got to make a decision by Thursday. All righty? All right. Now we're going to have some real fun. Now I'm going to start calling on some people. I'm going to put the last 3 days all in one problem right now. Reflections, translations, rotations, all in one problem. Go ahead, take a second, graph triangle ABC. We'll have a good time afterwards. Because of the lockdown, we'll probably go right up to the bell today. Okay, after you have it graphed, first step, take part A, take triangle ABC, reflect it, reflections over the x-axis, over the x. This is what we did on Friday. All right, so go ahead, reflect it over the x, and the directions do say graph and state. So I'm going to call on somebody and ask for what the coordinates of the A prime, B prime, C prime are in a second. But go ahead and reflect that triangle over the x-axis. Distance stays the same. And look, if anybody's missed days 1 or 2, they're up on YouTube. Not my problem anymore, right? 1, 2, 3, 4. 1, 2, 3, 4. All right, can you give me those coordinates of A prime, B prime, C prime? When you're ready, what are those coordinates of A prime, B prime, C prime? Test, let's go. Here we go. A prime.
2.
All right, good start. We're off to a good start. B prime.
6.
Oh boy. Now it's time to finish.
8. -1.
There you go. You can stay in class. Good. All right, everyone's good. All right, no issues there. Nice little reflection. Hey, I'm going to get fired up now. We have to pay attention to the directions because as I go to part B, you now have 2 triangles up on your graph. Which one is going to get affected? Read the problem. Now we're going to do a double prime triangle by translating the single prime one. So I'm not going back to the original. I'm going to do this translation on the single prime one. And what am I going to do? -6, -2. So you guys that were here yesterday, how is this triangle going to move? -6, -2. Where's it going to move? Jared? Let's go, everyone go. Take your prime triangle. Left 6, down 2. And again, I'll ask somebody for the new coordinates. All right, double prime coordinates, double prime. Let's do this. Ooh, Shara, here we go. A double prime.
-4,
1 for 1. B double prime.
0, -6.
Good. 2 for 2. Don't screw it up. C double prime.
2,
We got a winner there. 2, -3. Everyone's good. Ooh, now here comes the tough one. Now we're going to do a rotation of 90 clockwise. Clockwise, so I'm telling you the direction. And make sure I got 3 triangles up here. Which one are we going to perform the rotation on? I got 3 of them up here. Which one do I rotate? The double prime one, the previous one. So, all right, I got my paper in front of me, or I memorized the rule. 90 clockwise. Where am I turning my paper? To the right or to the left? Clockwise. Oh, boy. Think of a clock. Ready? To the right. So everybody 1/4 turn to the right. And now look at your double prime triangle. And on the side, off to the side, I know it's awkward, but off to the side, name where those new coordinates landed. All right, so 1/4 turn to the right. You look at the double prime triangle. and write down where the new coordinates are. And then graph it last. If you guys are memorizing the rules, you want to look for negative 90, right? 90 clockwise is the same as rotating at negative 90. All right, so if you guys are looking back at the previous page, you're looking at negative 90 here. One quarter turn to the right, and looking at the double prime triangle and writing down where the coordinates moved to. Whew, we are going to need a superstar up here to tell us what these coordinates are. All right, we ready here? Gonna need a superstar here. This one's a tough one. Rotations are always tough at first. 2's here, or I'll take Simon. Sure. Okay, here we go. Ready? Come on, I got faith in you.
I don't think I have it. I got the last one wrong.
What do you have for the A triple prime?
I don't have it.
Okay, turn your paper to the right.
Nope. The last translation, if it's minus
Yep.
6-2.
-2.
Or yeah.
Yeah.
How is it that far down?
What do you mean?
You're moving every point down 2 into the right or left 6.
Okay. Left 6, down 2. Yep.
So how is yours that much?
What point don't you think matches up? I'm going 1, 2, 3, 4, 5, 6 to the left, down 2. 6 to the left, down 2. 6 to the left, down 2. What's not matching up?
I don't know. I did it wrong.
You see, we're going all my, and I'm talking about the single prime ones here, not the original triangle.
Oh yeah, that's what it.
Hey, that's why we got the directions here, right? The image of A prime, B prime, C prime. We good? Already heard from Shari. Somebody new here. There we go. Vinny, you gonna help us here? You sure?
Yeah.
All right, man. We'll see. Triple prime, A triple prime.
-3, 4.
All right, he's got it. I got faith he's going to have the rest now. -3, 4. If anybody had, quickly here, let me do, can I do this in my head? If anybody had 3 -4, the sign switched. That means you rotated it in the wrong direction. You went to the left instead of the right if you had 3 -4. B triple prime, Vinny.
-6, 0.
Yep. And how about C triple prime?
-3, -6.
Yep. All good? All right, final one. Hey, I'm trying to trap you. I'm preaching to read, but I'm still trying to trap you. What do I mean? Yeah, I'm that guy that's going to do quadruple prime. I don't care about that. But I'm going to reflect what triangle, though? The original one. So don't go back to the triple prime one. It says the image of triangle ABC. So I'm going back to the original one and reflecting it over y equals -2. What type of line am I asking you to reflect over there? Woo! Jonathan, what type of line's y equals -2? Horizontal. So here you go. Let me graph it up here for you. Y equals -2. Everyone's reflecting the original over that line. So count the number of units away and go that same distance on the other side. But again, make sure it's triangle ABC. This stuff's it's pretty easy, but you just got to make sure you're doing it on the right triangle. The correct one, anyway. All right, how about those coordinates? When we're ready here. Drew, here we go. You ready?
Yep.
All right, come on.
A is 2, -5.
All right.
B is 6, -8. C is 8, -5.
There you go. Drew can do it. So can you. Right, Drew? Good job. Good work. Anybody else? We good there? Okay, so all I'm going to say is you just got to pay attention to which one you got to transform. All right, because I may always go back to the original. All right, enough of the graphs. All right, let's get off the graphs a little bit, but let's keep rotating. Here we go. So here's what I'm going to do. I got this triangle here, and I'm going to rotate it around L. So here's what I want you to think about right now. You are literally holding on to line L, and you're just going to whip this sucker around line L, and it's going to form a 3D object. What 3D object is it going to form? Because it's not a triangle anymore. All right, so I'm going to whip this thing and keep whipping it around and around and around, and it's going to form something. All right, so if you guys need a better visual, here you go. So I'm going to take this triangle and rotate it around and around and around. And what predictions, what 3D object it's going to form before I do it? It is going to form a cone. So everyone see as I keep rotating that triangle around a line, it's going to form a cone. Yep. So here. There it is. There's my cone. Looks beautiful. So that's when I rotate a triangle. All right, what happens if I rotate a square or a rectangle? It could be either here, a square or rectangle. So now I'm taking line L, cranking that thing around and around and around. Predictions? What's that 3D object called when I do a rectangle or a square? Oh, ready? Cylinder. Yes, that's called the cylinder. And what about the circle here? What do we think? Rotate the circle around. Called A. There it is. Called the sphere. Yep. How do I draw a sphere? You do a circle. You put the equator in. And then the back side of the equator in dashes, and you got yourself a sphere. Congratulations. All right, so we know what it forms. Now let's put some measurements on it. All right, with some Regents questions. I got these questions I got off some old Regences before we end today. Which three-dimensional figure will result in a rectangle? All right, so looks like we're rotating a rectangle. That's got 6-inch and 5-inch sides. And we're going to rotate it around the longer side, so the 6-inch side it looks like. All right, it's going to be continuously rotated around the longer side. Wait, we just talked, anytime you rotate a square or rectangle, what's it going to form? Cylinder, so we can get rid of choices 1 and 2, right? It's not a rectangular prism. Now the question is, what's the height and the radius going to be? So again, everybody, we are going to rotate it around the longer side. Wherever you put the 6, that's where we're going to rotate it, right here. So we're going to rotate our cylinder around and around. What's the height and the radius going to be?
Do you always rotate it around the long
No, I could rotate it around the shorter side, but it just goes in the problem. It says rotate it around the longer side. So it could be the shorter side. It's just in the direction says the longer. So we know it's going to form a cylinder. What's the height and the radius going to be now? Well, if I kept rotating it already, here's your cylinder, right? Looking like this on the side. What's this length going to be? This length right here. Here's my cylinder, right? Rotating it around. What's this side length going to be? 6. And is this referred to as the height of the cylinder or radius? Remember, radius is right here, right? There's your radius. So that's my height, 6 inches. So a height of 6. Ooh, I didn't talk about this one. Let's see if you can still get it though. A quarter circle, not a half or a full circle, a quarter circle, and I'm going to rotate it around the y-axis. What's it going to form? So I got this quarter circle here. I'm going to rotate it around the y-axis. Thoughts there? Not a full sphere, right? Because it would be a full, if I continued it up there, that would be a full one and rotate it around, but it's only going to be a hemisphere, half one. And then one more. Square. Guess we're labeling it math. Every side is 7 inches. And we're going to rotate it around AT. Well, let's eliminate 2 of these choices right now. It's going to form a what? Definitely. Cylinder, yep. So not a cone, that's a triangle. All right, let's think about this visually, right? I rotate it around and around and around. Is it going to have a radius of 7 or a diameter of 7? And again, remember, there's a radius. There's the whole diameter. Right? So as you rotate this around, do we think the radius is going to be 7 or the diameter will be 7? Yeah, hey, here's my center point, right? So this right here would be a radius on this side, and then when it rotates around, another radius on that side for 7. So the diameter would actually end up being 14, not 7. All right, so it would have a radius of 7. Diameter would be 14. All right. Okay, I don't think there's enough time to get out Chromebooks or anything, but everything's out of the packet tonight. You guys know what's on the quiz now. We'll review tomorrow. Reflections, rotations, translations.